Okay, so looking at the modulus now. So the modulus, very specific type of function or type of operation that we're going to be using. So either called the modulus or sometimes called the absolute value. And the modulus or the absolute value of a number is the positive value of that number. So if you think about something that we would use modulus for, you're thinking about things like distance, area, things that are always going to have positive values, even if the the things that we use maybe to find that wouldn't always have positive values. So even thinking about how in coordinate geometry, when you would have done that, that would have represented the distance from B to C. Okay, so that would have represented the distance from B to C. We use that notation with the two lines. So that notation there is the notation for modulus or absolute value. On your calculator, it might be written as that abs button. Okay, that might be how it's written on your calculator. So just so you know that you're able to find it, or alternatively something like kind of that. Okay, so either one of those probably is how it appears on your calculator. Making sure that you know exactly what the modulus is. So the modulus takes the input, takes whatever we put into it inside those two lines, and then spits out the positive value. So what that means then is if we're told the modulus of something is A, for example, then the thing that we put inside the modulus there could be A itself, or it could have been minus A. So what we mean by that is thinking the modulus of 3, the positive value of that, of course, is just 3. But similarly, if I have the positive value, the modulus of minus 3, the positive value of that is also 3. So in terms of that, then, what's inside the modulus could have been 3 or could have been minus 3. The other thing to note as well, then, is x squared is equal to a squared. So no matter what we put in, minus 3 or plus 3, if we square both sides, we should get the same result. So that's going to be a tool that we're going to be making use of here as well. So making sure, I suppose, first of all, that we're happy enough with what the modulus is, so that if we were told that x is equal to 7, we would be happy enough that that means that x is either 7 or x could be minus 7, that either of those values, when I apply the modulus, would give me an answer of 7, the positive value. So we're going to be using that idea then in solving what we call modular equations or modulus equations. And a modular or modulus equation is an equation where, I suppose it's fairly self-explanatory, in the name we're using that modulus notation. So we might have the modulus of something plus something is equal to something else. And we have two methods for solving these equations, and they come from kind of this note that we had up there. So the first method is we think about what the modulus means. So say we have x plus a there is equal to b. Well, that means that the part inside the brackets, the x plus a part, it must either be equal to b or it could be equal to minus b, because when I apply the modulus of b, of course, is just b, and the modulus of minus b is also b, taking the positive value, the positive sense of that. So either one of those will spit me out a positive answer. So I can use that then to work out the value of x, or the value of whichever unknown that I have. So that's method 1 here on the left. So we isolate the modulus part, the x plus a part, and we put it equal to plus b and minus b and solve for those two possibilities. That left-hand side probably requires a little bit more understanding of what the modulus is, but it's also a little bit quicker to do in practice. Because method 2 requires us to square both sides. And when we square both sides, we need to make sure that we do in fact square both sides. So we're not doing a situation where, say, for example, like a square root, when we square both sides, we just end up with the x. We're actually actively squaring out that entire expression there. So it's not that squaring just removes the modulus part. What we're actually squaring is the part that was written inside the modulus. So we're squaring the expression that was inside and the expression that was outside. And we use that then to solve the quadratic to get our two solutions. So either way, we should have two answers. We can easily check them then by subbing back in. So some of these earlier ones you might be able to do by kind of just having a kind of look at it, I suppose. So let's do it in the two methods here. So method 1, we're told x minus 8 is equal to 3. So taking the expression that I have on the inside there, which is the x minus 8 part, I know that that expression could be equal to 3, and hence the modulus would be 3, or it could be equal to minus 3, because if I took the modulus of minus 3, again, I would just get a positive 3. So solving that one, I get x is equal to 11, or x is equal to 5. That's my two answers. So let me see, have I got that one right there? plus, x is equal to 5 or x is equal to 11. Okay, so my two answers for that one. In the same way then I could take the expression I have on the inside there and the answer and square both. Okay, x squared minus 16x plus 64 equals 9. So x squared minus 16x plus, let me see, 55. So on two numbers that would multiply to give me 55, add to give me 16. Of course, we're a bit lucky here, I suppose, in that we're working kind of on a second method, so we already know the answers. But again, x is 11 and x is 5. So either way, it gives me my two solutions. We can see the left-hand side way a fair bit quicker, the right-hand side way just maybe a bit more methodical. Now, what I will say is it's good to know both ways, and it's important that you know both methods, okay? One is not necessarily better than the other. One thing to note is we have to know the second method to be able to do the next type we're going to be looking at, but similarly we have to understand the meaning of the modulus, and that's more to do with the first method. So kind of neither is really more important than the other, you have to kind of know both. So looking at the second one now, when we have two modulus or moduli if you like, when we have two modular terms, we have to use the second method, and the second method was to square both sides. So when we have two of the modulus there, we actually can't just do a normal kind of like say that it's equal to the positive, say that it's equal to the negative part, because that's going to get too confusing. And in fact here we're only going to really have one answer, because when we're setting two modulus equal to each other, as we'll be doing here, I'm going to take the second modulus over to the other side. What we're really looking at, if we think about the modulus as a function, is we're looking at a point of intersection. Okay, so we're really looking at a point of intersection here, and there's only going to be one such point. We need to square both sides to find that point. Let's give that a go. So x squared plus 2x plus 1 equals x squared plus 10x plus 25. Okay, now simplifying that down, I get minus 8x equals 24, which is going to give me that x is equal to minus 3. So just one solution here, and as I said, we will only have one solution in a modular equation like that with two modulus, because we're essentially finding a point of intersection between the two modulus equations there, between the two modulus functions. So just something to watch out for with those ones. Let's keep ourselves moving. We're going to jump into an exam question. So given that x is minus 3 is a solution to this equation, find the two values of p. So this is the 2021 exam question here. So jumping in with x is minus 3, we get minus 3 plus p is equal to 5. Okay, and I can use either method here once I've kind of established that idea. Okay, once I've established that idea, I can use either method. So first of all, I could say that the minus 3 plus p must be either equal to plus 5, or it could be minus 5, because those are the two values that when I take the modulus, I would get a negative answer. So that would mean that p is either equal to 8, or p is going to be equal to minus 2. Okay, and if we tried both of those out, for that one, minus 3 plus 8 is of course 5, and the modulus of 5 is just 5 because it is already positive. And similarly, minus 3 minus 2 is the modulus of minus 5, which of course again is just 5. For method 2, we're just going to square both sides, get an equation in p, and solve that equation. So 9 minus 6p plus p squared equals 25. So p squared minus 6p minus 16 equals to 0. So two numbers that multiply to give me 16 but will add to give me 6. So p minus 8 and p plus 2. So p again is 8, or p is minus 2. So the same answer is either method. So you can see there in these simpler ones or these kind of easier ones, either method will work. But noting again that we have to be able to use the second method. So just kind of making sure, kind of weighing up our options there in that one. So find the two values of m for which this equation is equal to 11. So again, two methods here. So we either say the middle section there, the part on the inside. So noting how I'm writing it now without the modulus all these times, that's either equal to 11 or minus 11. So that's what could be on the inside of my modulus. So that means that 3m then is equal to 6, so m must be equal to 2, or else 3m is equal to minus 16, and m could be minus 16 over 3. Same thing again then if I do method 2, I'm going to be squaring both sides. So 5 plus 3m squared equals 11 squared, so 25 plus 30m plus 9m squared equals 121. So 9m squared plus 30m minus 96 equals to 0. Okay, I'm just going to jump straight into an answer here. So 3m plus 16 and m minus 2. So I get, again, m is minus 16 over 3 and m is equal to 2. Okay, so again, same idea either way. Whichever method we use, making sure that we can get the same kind of answer out is really important, and we should be getting the same answer out. So I suppose that's definitely something to notice. It should be the same answer either way. So let's just do, I think, one more practice question here I want to look at for this video. It's just another question with two modulus equations for us to do. So when we have two modulus, we're just going to have to square both sides. We can't do the other method of taking the positive and the negative part because both sides have a modulus. So we get x squared plus 2 over 5x plus 2 over 5x plus 4 over 25 equals x squared minus 1 over 3x minus 1 over 3x plus 1 over 9. Okay, simplifying all of this down now. So at the minute I have, let me see, 4 over 5x plus 4 over 25 equals minus 2 over 3x plus 1 over 9. Okay, so let's just simplify that down now. So I'm going to bring the 2 over 3 to the other side. So 4 over 5 plus 2 over 3 gives me 22 over 15. 22 over 15x. And on the other side, I have 1 over 9 minus 4 over 25, which is minus 11 over 225. And dividing across there with the 22 over 15, then it's going to give me an answer of minus 1 over 30. Okay, so we get one answer. As we said, when we have two modulus, we generally just get one answer because it's a point of intersection. So key thing with that first part there is just understanding the idea of what the modulus is and being able to apply both of those methods. But I suppose at the very least, the second method there is definitely one to make sure you know, because you have to have that one to be able to do the equations with two modulus. So we're going to look on then and look at graphs and look at inequalities then using the modulus there.